Okay, thank you for coming. My name is Laurent Rosenfeld. Um, I've been using Perl 6 for about I've been using Perl 6 for about 6 or 7 years by now. First a little bit and then more and more. But I had trouble having opportunities to use it at work, and I finally found some opportunities. That's what I want to talk about today. My current work situation is I am working with a program that I will call admin. It's not the real name. The real name contains admin, but it's a little bit more complicated. But I just don't want to give these details. And it's a very large application, a huge monolithic application for managing customers in a very large telecommunication operator. And this application, admin, is running on Open VMS, so it's top technology of today, as you can imagine. It consists primarily of 3,000, almost 3,300 programs written in a proprietary language, which I will call G, which is roughly equivalent to what you could do with PLSQL on an Oracle database. And the glue language for all these programs for scheduling process and all this thing is DCL. DCL stands for Digital Command Language, so it's the old digital or tech company which created it. And we have about 750 of those glue language programs. So it's more or less equivalent to what you would do with a shell on Unix. So our team is using a few dozen programs under VMS, but we're stuck with Perl 5.8. So it's not exactly top technology. I mean, we're using many more Perl programs on Linux servers, so we're not only doing that, but at least on these platforms, we're limited to 5.8. And of course, there's very little chance that I will ever use Perl 6 on a VMS architecture, you know. You can imagine, if we're stuck with 5.8, we're not going to get Perl 6 anywhere. Or perhaps I will have to compile it and do everything, but I just don't want to do that on VMS anyway. So, besides that, this admin application has to be replaced in some time because it's really getting old. We don't find the software and hardware that we need, so we need to replace it. So we will move admin to Linux as far as the operating system is concerned. Then we migrate the database to Cassandra, which is a big data NoSQL database management system. And the G programs will be translated into Java. And then the DCL program, the 750 programs that I mentioned, which are more or less looking like shell, will be rewritten as shell script. But we cannot really translate them directly because they are doing things specific to the OpenVMS system using commands which are specific and which cannot be really translated directly into shell script or whatever, bash script or whatever you want to use. But in this context, still, I was able to use Perl 6 grammars to do two things, two small sub-projects. One of them was a proof of concept or prototype, if you want, translation of a small subset of the G programming language into Java. that was about 2.5 or 3 years ago. I will come back to that, but I will only very briefly mention that one, because the other one which I want to talk about is more important. And so the second one was a detailed analysis of the DCL script for the purpose of automatizing the documentation. So in other words, what I was doing there was to parse the DCL script and find out what they were doing and populate a documentation database. I will come back to that with some links. So for the first of the two sub-projects was translating G programs to Java. So what we did is we used the Perl 6 grammar to generate Java code from the G programs. This was, as I said, it was a proof of concept. It was in the context of the request for proposal. So it's not, it's very early in the project. We only translated a very small subset of the G syntax into Java code. We generated Java code that did compile cleanly and even run, provided we were putting the right technological infrastructure or environment around it. Having said that, our company's bid was not retained, so we were out of the market. However, one of the other companies, one of the shortlisted bidders, decided to ally with us, and eventually they won the tender. So, because thanks to that, we were back into the project again, but as subcontractor, not as main contractor. Yeah. So the second sub-project was to build a complete documentation database. Well, we wanted to have a complete view of the object relation in admin. When I say object, it's a very fuzzy word. It doesn't mean object in the sense of object-oriented programming. But, you know, every object, an object might be a database, might be a table in the database, might be a field in the database, maybe a program, maybe a scheduler or anything like that. So what we wanted to have is a complete view of the relations between the various objects within the application. The type of relations we were looking for was, for example, belonging to. Field A belongs to table X and also belongs to table Y and table Z. Or the other way around, containing, table X contained fields A, B, and C. The other type of relations we were looking at were launching program. One program is launching another program, so we want to know what's going on. Or this program is launching this and this and this circumstances by these other programs. The other type of thing we wanted to know is this program reading data from this table, or where does this program read data from? Where does it write data to? And so on. Having done all this work of gathering all this information, then we saw that we store all this relationship into a graph database, and the one we're using is Neo4j. I don't know if you know it. I'll just give an example of what it looks like. This looks like that. So each node in this graph is either a program or a table or field in the table, and this is just a snapshot. When you have the real one, if you double click on one of the nodes, then you get further information, more detail, or going what are the program affecting this node, and so on and so forth. Now, how do we populate this graph database? For most of the objects, it's relatively easy. I mean, for fields, tables, job schedulers, and many other objects, we just have a program written in Perl 5, which use a lot of regexes to extract the data. And then we feed it to Neo4j, to the Neo4j graph database. The language used by Neo4j is called Cypher. More or less looks like SQL. So as I said, it's mostly done with in Perl 5 with lots of regexes. Now, that's for all the static thing. This field belongs to this table and this type of thing. For programs, it's a little bit more complicated. For the G programs, we have already written a grammar to convert it to Java. It's not completed, but it's 98%, 99% completed. So we can use the output of this grammar to feed the Neo4j database. So it's relatively easy to generate Cypher code for populating Neo4j. Now, we didn't have the equivalent for DCL script because, as I said, it's almost impossible, as far as we can see now, to translate directly DCL script into shell script because it's doing very particular things which are very specific to OpenVMS. So it wouldn't make sense to say, okay, we translate that into Bash shell, for example, because what it's doing is simply does not exist on a Linux platform. So we don't have the equivalent for DCL script, and that means that's really where I was able to use the Perl 6 grammar to pass each of the DCL script and generate two kind of outputs. On one side, CSV output, and on the other side, the Cypher output, which is used to populate the Neo4j database. So maybe I'll just give you now a small glimpse on what the DCL syntax looks like. It's ugly. Well, the first thing you can see here is that every line starts with a $sign. Well, there's one exception, is empty line don't need to have a $sign, otherwise every line has to have a $sign. Here the first line defines what is called a symbol, so I say W equal write sys output, which means next time I will be able to use W and the system will understand that it does write sys output, which is basically writing to the standard output. And so the next line, as you see, I use W, and that will print parameter 1 is P1. Now you can see on the second line, for example, that is funny quoting. It's unbalanced quoting. That's because in DCL, you would use, in this case, you would use one quote. Well, you would use two quotes to quote the thing, and then one additional quote to say, but I don't want P1, I want the content of P1. So, as I say, it's a pretty ugly syntax. The other thing you can see here that I have a loop there, and the only way we can make a loop in DCL is with the famous go-to here. There's no looping construct, so you have to define a label, loop, colon, and then you say go to loop when you want to loop. That's what DCL looks like. The other thing is the line separator is the statement separator is the end of line. What I just said, new lines are statement separators, but some statements may be spread over two lines, and for that you would end the first line with a dash, and that would tell the interpreter that the next line is a continuation of the current line. Okay, now I'm going to show part of the grammar that I have been using for passing this DCL script. So the first thing I had to take into account is that I could have most of the time a line ending with an end of line is a statement, but in some cases there are multi-line statements. So I had to define in my top rule that top rule is either a multi-line thing or a single line, and they are separated by vertical space. Then multi-line is a continued line, or a line with a continuation, ending with a dash, or a simple line. And line continued, well, it could be either a comment line, or it could be a line with a keyword, or it could be a line without a keyword. All these things will be defined in the next slides. But it ends up with a dash, which says the line continues on the next. So what is a line in DCL? This is slightly simplified compared to the real thing, but basically it's either an empty line or a description line or comment line, and then I have this thing line with keyword and line without keyword. This is for the purpose of my analysis. This is what I need. You could do it differently if you wanted to get something else. So now I will define the various tokens there. So the first one is empty line. So an empty line is either a line which has basically nothing or only spaces, or is a line which starts through the dollar sign and then has only horizontal space. So yeah, just one thing to mention here: alternation. I'm using here two types of alternation. The first one with double pipe sign and in the regex empty line with a single pipe sign. When you're doing it with two pipe signs, you're asking the parsing engine to look for the tokens in the order in which they are described here. So in other words, here I'm first looking for an empty line. If looking for an empty line in phase, then I'm looking for a description line, and so on. When you have only one pipe sign, then you're asking the parsing engine to look for the best match, so the longest match in reality. But in the first case, I really wanted these things to be done in that specific order, because it was important for me that I first want to exclude empty line, then I want to exclude description line, and I want to exclude comment line before getting to the things that I want to extract. So we need to extract program descriptions. So description line, it can be either of two things. I mean, because of history, there are two types of description line in the program. So we need to extract the description. So one is a variable or a symbol called description and an assignment to something. And the description could also be a comment. So I forgot to say it, but the exclamation mark means it's a comment. So some of the comments I need to extract information because they contain the description. Command line start with an exclamation mark. I have to be quick. Apparently I'm a bit late. I guess I have to cut it short right now. So anyway, I thought I was going to talk faster. So anyway, the slides will be available to on the internet very soon. Just a quick note on performance. Is Perl 6 fast enough for that? We had almost 750 DCL script representing 5 megabytes and 106,000 lines of code. The whole thing runs in less than 30 seconds on this laptop here. So it's quite good. And we can safely run the process every time there is a new release. We can run the process again to update all the documentation. So conclusion, well, I was very happy to be able to use Perl 6 on a real project. Yaldi. Using a real grammar really made sense for this part of the project because because the script is complicated. And well, thank you for listening. And if you have any question, do we have time?
It's 20 minutes and then the lightning talk starts.
So maybe.
Might be easier just catching him on the way to the lightning talk.
Okay. Okay. So the slides, well, I've written that they are available. They will be available very soon on my GitHub repository. So it's not yet there. Thank you.